Hi everyone, I'm Sid. I'm a PhD student in the particle physics group, and today I'll be talking to you about simulating particle physics straight on your laptop. So in this talk, I will start with an overview of what we do in particle physics and then mention some of the computational tools in this field. And then I'll highlight my work, which is on simulating these types of particle physics events, or what we call event generation, and then bring up some interdisciplinary opportunities that are available. Okay, so an overview. Okay, so particle physics. What are we trying to do? So we're trying to find the building blocks of the universe, as we like to say. So the most common ones that most people know about are your electron, your photon, which is light, and the very recently discovered Higgs boson. Another popular one is the proton or the neutron, but these are made up of these orange ones called the quarks. So to observe these particles, we must we can't see them on a day-to-day basis or in a lab. We have to look at very specific high energy conditions where these particles are traveling at 99.99999% speed of light. And because of it's such a high energy physics event, as we like to call it, you eventually end up with a collision between two particles, which leads to hundreds of particles being made. So, how do we research this? So, us particle physicists are divided into two subgroups. So, we have the theorists like me. So, we make new theories and models with more or fewer particles and try to see if this new theory fits our understanding of the universe better or not. And then there's the experimentalists who use detectors to make very precise measurements, either to validate a theory or to debunk it. But there's also this table tennis kind of effect where theorists can take the values that the experimentalists provide them and use it to fine tune their models slightly as well. And those type of theorists are called phenomenologists. So how do we do this computationally? So on the theory sides of things, we do a lot of complex analytical calculations with Mathematica. And then we've got this, the biggest part of our research is to find probabilities of specific particles to be seen. And for that, we have to combine a lot of possible scenarios. And we do that using numerical integration. And we also, once we have our theory, we try to simulate it to see if it matches experimental data. And what my experimentalist colleagues do, start from detector data and convert it to measurements. Then they handle very, very large data sets. So we've got like terabytes or exabytes of data for 10 to the minus 17 seconds of time. And then what's quite recent is that they're using machine learning to split signal, which would be the particles you're interested in, from backgrounds, which is the ones you're not interested in. And yeah, there's a big AI push in that region. But I'll talk about what's on the green side of things. And talking about how we simulate our models. And this is the tool I work on called event generators. So going back to the photo I showed you earlier, so we've got a ton of these particles being created by two particles colliding. And the way we model it, it actually, we can use our models to make it look something like the photo on the right. So it's not quite the same, but it gets pretty close. And we're trying to make it as close as we can. So from theory, we can get the probability of a particle to be created, as I mentioned. And the way we do this is by we combining the probability with a random number generator. So for those who work with Monte Carlo or Monte Carlo simulations, this is the kind of stuff we do. And because we've got hundreds of particles which have different energies and momentums, we used object-oriented programming, mostly in C++. Anyway, the fun part, right? So as I mentioned, you can do all of this on your laptop. So you can download a specific event generator. So there's three big ones. One's called Herwig, which is the research group I work on, but there's also Pythia and Sherpa. They've got like a one-page guide to how to run a full simulation of LHC, which describes what you're doing and how doing that gives you some results. Although you don't get to see very like cool events and stuff, you do get to see some interesting results. So on the graph to your right, you can see data in black, and we've got a pretty decent simulation of that data with the red. And so my job or my PhD project is to make this software more accurate. So as you can see on like between the center and the right, it starts to deviate. So that's where I work. Okay, so in terms of interdisciplinary work, we are all trying to reduce our computational usage. In our the Atlas collaboration, which is responsible for one of the detectors, the LHC, they did this study where they showed that the predictions for computational use is going way over our current budget, and we'll have to do very aggressive R&D rather than just letting computers run for days simulating events. And a good chunk of this usage is event generation. So if you look at the pie chart, it's around 17%. So we're trying to find A, less time consuming, and B, much more computationally effective solutions. This will save both money and electricity. So the direct short-term solution would be finding bottlenecks in the code and using profiling, but the long-term solution is going to be using GPU programming to simultaneously do all of this. And this is where I want to collaborate. So yeah, so I've been working on a little side project. I call it GPU FGen. And right now I'm trying to do my event generation simultaneously using CUDA on an NVIDIA GPU. So at its current state, it does the simple tasks on the GPU and it's really fast at it. But you move on to something more complicated, like a while loop with an if statement for people who do a lot of programming with C++. They will know that this is going to be very rough and very hard to code on the GPU. But for the stuff that works, there is a public repository, so do feel free to check it out yourselves. You'll need CMake and an NVIDIA GPU, but besides that, yeah, everything should be working as it does. And that's all I wanted to mention today. So here are my details. And on the QR code, you will find these slides, a link to the Herwig event generator, and also a few more ways to contact me. Thank you very much.